Hello everyone. Today we continue the topic for 6.6 standard solution. I will cover two subtopics for today, 6.6 standard solution and also 6.7 neutralization. Let's look into it. Okay, standard solution. So, what is the meaning of standard solution? Okay, for your information, standard solution is a solution with known concentration. Means, we need to know what is the standard solution and what are the uses of the standard solution. We need to prepare the standard solution according to the mass of solute and the volume of distilled water so that we can produce a good standard solution. Okay, how we want to prepare a standard solution by diluting aqueous solution? Okay, right. So we need to know what is the method that we use into the preparation of a standard solution. That is dilution method. Okay, so how this method are going to use? This method involves adding water to a concentrated standard solution, which means that we know the stock solution need to produce a more diluted solution. Okay, for example, from the diagram, from concentrated solution, we will add distilled water, so we will produce dilute solution for a standard solution. Okay, so we will need to know how we want to calculate. So by using the formula, the number of moles of solute before dilution, M1 V1 means before the solution, equal to the number of moles of solute after dilution, means N2 or M2 V2. Okay, right. So continue here. So M1 is the molarity before the dilution. V1 volume before dilution. M2 molarity after dilution. V2 volume after dilution. Okay. For example, we wish to prepare 500 cm cube of 0.1 mole dm -3 cube, copper 2 sulfate solution. So given to us the M2 and V2 because you wish to prepare, we want to prepare means this is our product. So by using the formula, just substitute the value, 500, 0.1, right? So this is M2V2 because we want to prepare the solution. From means we use the stock solution, the original solution, which is 2.0 mole dm -3. So we put here M1 as M1. So we don't know what is the value for V1. So how we want to find V1? By using formula. So we get 25 cm cube. So the conclusion is 25 cm cube of stock solution of copper 2 sulfate, CuSO4, needs to be diluted using distilled water until 500 cm cube solution of copper 2 sulfate, CuSO4 is obtained. Okay, let's see the example. Figure 6.30 shows 70 cm cube of 2.0 mol Dm-3 nitric acid. Okay, that is diluted to X mol Dm-3 when 25 cm cube distilled water is added. Calculate the value of X. Okay, so to get more information, to getting more understand, okay, so by the diagram we can see here. Okay, so before dilution, okay, we need to dilute 75 cm cube of 2.0 mol Dm-3 nitric acid, right? Okay, so after dilution, okay, we're not sure what are the molarity, okay, and then the volume already given, okay, so, okay, since we have two volume here, okay, distilled water is added, means we need to total up the volume, okay. Okay, we look here. Okay, so you must write down step by step. You cannot skip the step so that you don't write a silly mistake. For example, here. Okay, M1 2.0, right? Okay, V1 75 cm cube. Okay, yes. This is from the question, right? But for M2, yes, we need to know the M2. Okay, V2, you must be careful since from the question, very higher order thinking skills, very kebat, they're not stated here. So you need to add 75 plus 25, okay, manually. So the final volume is 100 cm cube. The total of volume of solution, okay, you must add the volume, the original HNO3 for the previous one, then volume of distilled water. Okay, so just follow the formula, okay, and then you will get the final answer 1.5 mol Dm-3. Okay. Okay, next. Example 13. Determine the volume of 2.0 mol Dm-3. Okay, so this is the M1. Okay, M1. HCl needed to be pipetted into a volumetric flask 250 km cube to produce 0.2 mol HCl. So, given to you M2 also and then V2. So you need to find V1. Okay, by using the formula M1 V1 equal to M2 V2. So you will get, okay, 25 cm cube. Alright, next. Okay, so that's all about the standard solution. Okay, next we need to learn about neutralization. Okay, so you can see these three equations. Okay, so you need to know, okay, how they process the method of neutralization. Okay, so we continue for the last topic here. Okay, so the meaning of neutralization is a reaction between an acid and alkali to produce salt and water. Okay, this is the basic meaning. Okay, now so we look into the example here. Let's say we have nitric acid, okay, react with potassium hydroxide. Okay, so it will produce H2O. Okay, we know that the product is always salt and water. So you can remember that the last one is the product is water. Okay, this one you need to cross. Okay, this topic from chapter 3, how we want to get the chemical formula if two substances are reacted together. Okay, so the actual reaction that occurs only involve the combination of hydrogen H plus, okay, from the acid and the hydroxide OH minus. Okay, so we need to write down ionic equation. Okay, so this we call ionic equation. Okay, never mind. We look into the example here. Okay, so we have two types of equation, chemical equation and ionic equation. So how we want to obtain the ionic equation? Okay, since HNO3, okay, we divide it into two parts. Okay, H plus plus NO3 minus. Okay, so you tengok plus plus plus. Okay, so potassium K plus OH minus. Okay, okay, if you see here, okay, why we cancel out NO3 minus, K plus, K plus, NO3 minus here. Okay, why? Because we want to show that, okay, K plus and NO3 minus are considered as spectator ions. Okay, means that, okay, they do not change in their reactions. Okay, we call, we can say that, okay, the potassium and K plus and NO3 minus, okay, does not involve in the reaction because you want to write down the ionic equation, right? Okay, so H plus here, okay, just write down here, okay, OH minus, okay, we put here, then the product, okay, we put here. Okay, next. The applications of neutralization in daily life. So, okay, it's very common use in our daily life. Okay, milk of magnesia, MgOH2, can relieve gastric pain by neutralizing the excessive hydrochloric acid in the stomach. Okay. Shampoo with alkali in the shampoo neutralizes acid on hair. Toothpaste contains a base that neutralizes lactic acid produced by bacteria in our mouth. And then agriculture slaked lime, okay, which is alkaline, is used to treat acidic soil. Okay. Next, okay. Actually, the neutralization process, okay, we can determine, okay, by the process of titration. Okay, actually we have the experiment. Okay, never mind, during experiment I will explain more, but this one is about the color changes. Okay, what happen if we do experiment, okay, when using phenolphthalein and methyl orange. Okay, so if the solution from the experiment, okay, you get the colorless, okay, and then they turn to pink, that means, okay, the product or the solution is alkaline. Okay, the original color for phenolphthalein is colorless, so means if you titrate the solution, the at the end point, okay, we call end point here, when the end point, the last product, you can see that the solution still colorless, mean the solution is the acidic solution. But if the solution become pink, that means that is alkaline solution. Different with the methyl orange. Okay, the original color for methyl orange is of course orange. So if you doing the experiment for neutralization, the solution at the end they come to red color, so that is acidic solution. But if the solution turns to yellow color, the solution is alkaline. Okay. Neutralization also have a calculation. Okay, so you need to remember the formula. Okay, so we have here, okay, acid A, let's say we have acid A plus alkali B, so it will produce salt and water. Okay, usually the number of mole here is different. So we need to take note because from the formula here, okay, MAVA over MBVB equal to A over B. So you need to take note all of this. Okay, never mind. We will look at into the example. Okay, let's say we have 20 cm cube of 0.25 mole sodium hydroxide, okay, and AOH is neutralized with, okay, so means this is alkali react with 0.2 mole hydrochloric acid. Okay, calculate the volume of hydrochloric acid HCl needed for this neutralization reaction. Okay, okay, in examination they don't give you the equation. You need to construct your own equation. That's why chapter 3 very important. You need to know how to construct the chemical equation and balance the equation. Okay, so HCl acid react with alkali, of course, produce salt and water. Water is not too hard to remember. You just write down H2O, but you must be careful here. NaCl. So you know that Cl here will react with Na become an ACl. So make sure all of the equation from the reactant and the product are balanced. Okay, so from the question, okay, we put the information. Please write down. If you just directly write down the calculation, you will get confused. The first step you don't skip. Okay, molarity A 0.2 mole. Okay, Va. Okay, we don't know. So we need to find the volume for Va for the HCl. If you want to write down HCl also can. You want to get confused means MHCl. Okay, so that you're not confused. MHCl 0.2, VHCl. Okay, so you're not confused lah. Okay, and then MB is at NaOH 0.25. Okay, VB 20 cm cube. Okay, so by the formula given, okay, since A and B there are no mole here. Okay, some of the question we have two, right? Like I said 2 HCl here or 3. So here is 1. So you just substitute the formula. Okay, and then you last one you will get 20 cm cube. Sorry, 25 cm cube. Okay, for the examples you can find in the barcode scanner here. Okay, so that you can understand more. Okay, next, example 15. Okay, given to you the mass of zinc oxide is needed to complete the neutralization of 50 cm cube of nitric acid, HNO3. Okay, calculate the concentration of the acid in mole dm -3. Okay, so yes, this one you need to be careful here. HNO3 plus zinc oxide. Okay, so remember H2O, there are no changes, so you must remember. But the product salt here, you must be careful when you're doing cross section. Okay, kita reflect again. Okay. Okay. Hash and O3. Okay. So H, okay, H will produce H2O here. So we have NO3 minus. Okay, zinc oxide. Okay, oxygen already. Okay, go to here. Okay, so zinc. Okay, zinc you need to remember zinc is 2 plus, right? Okay, zinc 2 plus. Okay, cross with NO3 minus. Okay. Okay. So sorry, 3 here. Sorry. Okay. So the charge here is 2. The charge here is 1. Okay. So the final equation for the salt is zinc. Okay. NO3 ni 1 ion tau. Not confused. O3 is together with the O here. You cannot separate it. So the 2 here is here. Okay, zinc 1 and O3 2. Okay, that's why you got the salt here. Okay, then after that you must check the solution, the equation. Does the equation balance or not? Okay, zinc 1, 1. Okay, balance. Okay, we find the smallest first. Okay, oxygen is the largest one, right? Okay, zinc, okay, settle. Okay, H we have 2 here. So H2 here only 1. So that's why we put 2 here. So balance 2H. Okay, so settle hydrogen. Okay, now we have O here. Okay, O last one. We need to find the N first. So N we have only 2. N, 2N. Okay, here also 2N. Okay, so settle. Okay, O3 times 2, 6. 6 plus 1, 7. So 7 O. Okay, O3 times 2, O6. Okay, plus 1, 7. Okay, so settle. So balance lah. Okay, then you have the A is 2 mole, B is 1 mole. Means 2 mole of HNO3, 1 mole of ZNO. Okay, so now settle the chemical equation balance. Okay, so we need to find the number of mole. Okay, so given to you mass. Okay, you must remember how to find mole. Mass over molar mass. Okay, so mass over molar mass. So you got 0.05 mole. After that, then you compare the stoichiometric. Okay, ini. Let's say we have from the question. Okay, we need to find the concentration of the acid. Okay, so 0.05 mole here, we need to compare with the original equation. Okay, this is from the original. Means from the equation, from the balance. So we just expect that 2.0 mole of HNO3 react with 1.0 mole ZNO. Okay, so if from the mass, okay, we get 0.05 mole. So we compare the ratio based on mole ratio. Okay, so if we have 0.05, so can we get the actual mole for HNO3? Yes. Okay, means we divided by 2. 1.0 divided by 2, you got 0.05. So of course 2.0 divided by 2, you got 0.1. Okay, from here, then we can settle the final answer. Because the formula given to you that mole equal to mv over 1000. So again, check from the question here. Okay, 50 cm cube. Okay, 50. Okay. Okay, M molarity, we need to find it, and then over 1000 lah. Okay, from the question. And then, okay, you will find the final answer. So the molarity of nitric acid is 2.0 mol dm negative 3. Okay, never mind. After you make a lot of exercises, I think you will get more understand. Okay, so salts crystal analysis in daily life, we will continue for another lesson. Okay, that's all for today. Thank you.